inform your friends to rejoin. If you have any friends who have not joined, there is a issue with the network as well as power today. So it is disturbing us. Flow is getting disturbed. But like to join some people. Let us wait for them. Please inform your friends. It's already on. Arpit Anand, if it is not in the ring, you can connect externally one inverter or two inverter, three inverters, not a problem. Just if you are using one inverter, right, on time is becoming off time is becoming on time. That's it. Arpit Anand. If you are using any inverters externally for this or for the next one, five inverters, if you are using any more inverter this side, then what happens here? It is changing on time to off time to on time. So frequency will not be changing. Wait, Srishti. Please wait. Yes. Pranit, we think of this because today already it is getting disturbed a lot. So we'll think of that, Pranit. Yes. I think mostly whoever is interested is in. Let me continue. Now, we were discussing about a bistable circuit. In that, we have used a NOR-based memory element. NOR-based memory element. Let us see what can be that. As we discussed, NOR gate enable and disable conditions. Here we are applying 0, 0. What is 0 for NOR gate? Enable input. When 0 is enable input of NOR gate, output is depending on, yes, output is depending on Pavan Kumar, Gumuliri Pavan Kumar. Yes, there was a disturbance. It got disconnected. Once again, we are connected. Pawan, it is for everyone, not for you only, right? So now, logic 0 is enable input of NOR gate. Logic 0 is enable input of NOR gate. If one input is 0 for NOR gate, output is complement of other input. For this NOR gate, one input is 0, output is complement of other input. What is output here? Other input is what? Y bar. And again for this NOR gate, one input is 0, other input is what? X. Output is X bar. After that, by substituting Y equals to X bar, if I am analyzing here, what we get here? X bar whole bar is X. And now X equals to Y bar we have decided here. So I'm substituting here. Y bar whole bar equals to Y. That means it is remaining in X and Y only. It is remaining in X and Y only. That means it is stable in existing. If XY is 0, 1, it remains in 0, 1. If XY is 1, 0, it remains in 1, 0. Because these input conditions are giving that stable. So the existing XY is stable now. If I apply AB00, 0, it is remaining in X and Y. That is nothing but previously existing, it continues. When AB is 0, 0, X and Y are previous. X and Y are previous. Right? So it remains in existing only. It can be 0, 1 or 1, 0. It will be remaining in the same. Not only this, it must be in 0, 1 or 1, 0. That means these two outputs XY must be complementary. Then only we can guarantee this function. Point should be understood correctly. If XY is 0, 1 or 1, 0, it remains in the same. Not only this, it must be complementary either 0, 1 or 1, 0. If it is uncomplementary outputs on X and Y, we cannot guarantee its function. What is the function here? It is remembering. When AB are 0, 0, this circuit is remembering, which is stable. Which is stable. When AB are 0, 0, X and Y are previous. X and Y are previous. It is remaining in the same. It is remaining in the same. That is guaranteed if these two XY are 0, 1 or 1, 0. That means complementary. Simple thing is when AB 0, 0, it is guaranteeing it remains in the same. To guarantee that also XY must be either 0, 1 or 1, 0. If it is other than these, we cannot guarantee, or circuit is not guaranteeing it is going to remain in the same. If it is complementary outputs 0, 1 or 1, 0, then it can guarantee it remains in the same. What happens if it is uncomplementary output? I'm going to discuss. So you may be having it out. Instead of giving a statement, why can't you show me that if it is uncomplementary, what happens? The doubt everyone will be getting, right? Even when you are saying to me, I'll be getting same. Yes, similarly, I'm saying that if it is XY 0, 1 or 1, 0, it remains in the same. Expected function is satisfied. If it is uncomplementary, what happens? I'm going to explain. I'm going to explain. Please hold on. Once again, what is it here? When AB is 0, 0, X and Y are previous. X and Y are previous. That previous is guaranteed if XY is 0, 1 or 1, 0 only. That means XY are complementary, then we can guarantee. If XY are uncomplementary, we cannot guarantee. What is that? We understand. Hold on. If AB are 0, 0, it remains in the same. Previous, it is continuing. Conditions apply. What is the condition? XY must be complementary, either 0, 1 or 1, 0. If AB are 0, 1, what is here? If A is 0, B is 1. Then let us see what happens. If A is 0, B is 1. Which one should be analyzed now? For this NOR gate, one input is 0, output is complement of other input. Check correctly. As one input is 0 for this NOR gate, what is output? Complement of other input. But for this NOR gate, one input is 1. What is the output? As one input is 1, what is the output of this NOR gate? 0. It doesn't need to know what is the X. But to know what is that X, I should know Y. Dependency you need to understand. As it is connected to enable input, output is depending on what is that Y. But as it is connected to disable input, I don't need to know what is X also. Irrespective of X. X may be 0 or 1, doesn't matter. For sure, Y becomes 0. Why? It is connected to disable input. Concept we have discussed is useful now. as it is connected to 1. I don't need to know what is the x also. Even though x is changing, there won't be changes in y because this gate is connected to disable input. Point should be understood correctly. Here, when you are analyzing this NOR gate, if you want to know what is x, it is expecting what is y. If I know y, I can say what is the output. But when you are analyzing this logic gate, this NOR gate, as it is connected to 1, irrespective of x, output is output is here output will be 0. Anyone has any doubt? It becomes 0. If x is changing, doesn't matter because it is connected to 1. X doesn't matter now. X may be changing, x may be any value, but for sure it remains in 0 only. Is there any doubt? When you are analyzing a gate which is connected to disable input, we can say pakka what is the output. But when you are analyzing a gate which is connected to enable input, it is expecting what is the other input also to say what is the output, because output is depending on other input when it is connected to enable input. But when it is connected to disable input, irrespective of other input, no doubt output is becoming 0. If x is changing, it won't change. Even though x is changing, y will not be changing. For sure, it will be in 0 only. Anyone has any doubt here? So when one input is 1, NOR gate output is 0, irrespective of other input, because gate is disabled for other input. Even though x is changing, there won't be changes in y for this one input condition. Once it is becoming 0, now I know what is the inputs of this NOR gate. What is inputs now? 0, 0. For 0, 0, NOR gate output is becoming 1. NOR gate output is becoming 1. Irrespective of existing, x is modified to 1, y is modified to 0. What was earlier doesn't matter. But when I'm applying AB01, yes, xy becomes 1, 0. Will there be any change? No. Until you keep this 0, 1 as it is, there will be output xy 1, 0. I hope everyone is understanding. While analyzing logic gates or cross-coupled NOR or NAND, when you are applying 0, 1 or 1, 0, which one should be analyzed first? The gate which is connected to disable input. Because when it is connected to disable input, we don't need to know what is x also. Irrespective of x, we can say output is 0. Stable output is 0. After getting 0, now we can analyze other gate, right? So after getting 0, now for 0, 0, we can say what is it x. But without knowing y, I cannot say what is it x. That is the reason we are analyzing this gate first, as it is connected to 1, disabling the gate, output is 0. Once it is becoming 0 for 0, 0, NOR gate output is 1. So x, y are becoming 1, 0. Anyone has any questions? When you are applying 0, pakka it becomes 1, 0. After that, there won't be any changes if you are not changing AB inputs. If you are not changing AB inputs, it won't be changing. It won't be changing. Correct? Now, if I apply AB 1, 0, let us see what happens. If I apply 1, 0, what is here? A is 1, B is 0. A is 1, B is 0. What will be xy? What will be xy? What will be xy? Which one should be analyzed first? This gate. Why? It is connected to one input is 1. Then pakka output x becomes 0. Then once x is becoming 0, for this NOR gate, we have both the inputs 0, 0. Then it becomes 1. Y becomes 1. Understand correctly? For this NOR gate, as one input is 1, output is 0. For this NOR gate, one input is 1, output is 0. As it is becoming 0 for this NOR gate, 0, 0 is changing output to 1. Yes, y is becoming 1. Irrespective of existing, once again, xy is settling to 0, 1. That means again, it is modifying x to 0, y to 1. Irrespective of existing, yes, when you are applying 1, 0 on inputs, xy becomes 0, 1. Yes, Expected three functions are completed. What are the functions? So AB00 remembering, continuing in the previously existing. When AB01 modifying to 10 irrespective of existing. When AB10 XY is modifying to 01 irrespective of existing. Yes. Remembering, modifying to 10, modifying to 01. Yes, it is meeting expected functions. What is it here? Remembering, modifying to 1, modifying to 0. Expected three functions are completed. Anyone has any doubt? When we are applying 00, remembering, continues in the previously existing. When we are applying 01, irrespective of existing XY becomes 10. When we are applying AB10, irrespective of existing XY becomes a 01. Yes, sir. Remembering, modifying to 1, modifying to 0. Or changing contents to 1, changing contents to 0 are possible with the AB00, AB01, AB10. Expected three functions of memory element completed. Now, if I apply AB11, let us see what happens. Now, onwards is important. Generally, 11, you might have studied it is invalid. Why it is invalid? There only they are concentrating. Remember this. Generally, I can escape easily. What is that here? By applying 11, invalid. Invalid means not required to analyze. But there only they have framed a question already. Have been saying from almost 13-14 years this concept in this way, but 2017 GATE EC they have given a question. So invalid, correct? Why it is invalid? What happens if I apply? Because I know what is the logic gate functionality. Why can't I analyze? Let us see what happens. Right. Very good. Yes. Very good. Yes, sir. When ABR 11, let us see what happens. When you are applying that, A and B are 11. Suresh, please wait. I will answer your doubt. Please wait. If AB are 11, then this gate is disabled. This gate is also disabled. Am I right? This gate is disabled because logic 1 input is there. This gate is also disabled because logic 1 input is there. Then one input is 1, no doubt output is 0. One input is 1, no doubt output is 0. There won't be any doubt. One input is 1, confirm, irrespective of other input, output will be 0. Because NOR gate is disabled. NOR gate is disabled because one input is 1. Sufficient to say output is 0. Output is 0. Yes, when AB are 1, 1, irrespective of existing, X and Y are becoming 0, 0, which are uncomplementary outputs. We are not expecting uncomplementary output, or there should not be uncomplementary output, correct? But what happens when I am getting uncomplementary outputs? That is also important. When AB11 applied, what is the output we are getting? Both are 0, 0, which is uncomplimentary, which we are not expecting. It should not be uncomplementary output. There must be always complementary outputs. That's what we are expecting. From here itself, I've been saying that these two must be complementary. These two must be complementary. But for this input condition 1, 1, we are getting 0, 0 output, which is uncomplementary outputs. Right? I hope you are there only. Yes. When we are applying 1, 1, we are seeing uncomplementary outputs 0, 0. What happens if it is applied uncomplementary? Or if you are applying 1, 1, we are getting uncomplementary output. What happens if it is seen uncomplementary output? Let us see. Here itself, I mentioned that 0, 0, it is previous. There must be complementary outputs. But what happens if I apply input condition which are resulting uncomplementary output? After what may happen? Afterwards, what may happen? That's what is important. So after applying 1, 1 input condition, we have seen uncomplementary output 0, 0. If the next immediately, if you are applying 0, 1, for example, in the next sequence of inputs, if I'm applying 0, 1, no doubt it will be 1, 0. If I'm applying 1, 0, no doubt it becomes 0, 1. After applying 1, 1, if the next sequence of inputs is 0, 1 or 1, 0, there won't be any problem. Right? After applying 1, 1, we are getting 0, 0. But if you are applying immediately 0, 1, no doubt it becomes 1, 0. If you are applying 1, 0, no doubt it becomes a 0, 1. But if you are applying 0, 0 immediately, Check it correctly. One more important thing I'm analyzing now. What is it here? We are applying 0, 0. Before applying 0, 0, what was the inputs? 1, 1. With 1, 1, what was the output? 0, 0. When 0, 0 outputs are there, I'm applying 0, 0 inputs now. Be clear. Be clear here. What is it here? When we are applying 0, 0 inputs, when it was 0, 0 outputs, then if you are analyzing this NOR gate, this is 0, this is 0. For 0, 0, what is the NOR gate output? What is the NOR gate output? It becomes 1. Check it correctly. What is it here? For this NOR gate, this is 0, this is also 0. For 0, 0, NOR gate output is becoming 1. Once this is becoming 1, for this NOR gate, we have 1 and 0. Check it correctly. For this NOR gate, this is 1 is applied. This is 0, 1, 0. It becomes 0. It becomes 0. Right? Why are you analyzing this gate first? From input side, output side is same. Why are you analyzing this gate first? No priority here. Then why are you analyzing this gate? No. Let me analyze this gate also. What happens? Let us see. So assume that it is not there. It is not there. What is that here? 0, 0 is there. We are applying 0, 0. Now let me analyze this gate first. For this NOR gate, here one input is 0, other input 0. For 0, 0, for 0, 0, what is the NOR gate output? 1. For this NOR gate, existing 0 and 0. For 0, 0, what we get here? 1. Once it is becoming 1, for this NOR gate, 1, 0, NOR gate output is 0. NOR gate output is 0. Earlier analysis was giving 1, 0. Now you are getting that 0, 1. Which one is correct? Which one is correct? We don't know. See, once again, when 0, 0 outputs were there, if you are applying 0, 0, when uncomplemented outputs are there, when you are applying 0, 0, what happens also is important. What is happening here? If you are analyzing this gate first, it becomes 1 and other one will be 0. If I am analyzing this gate first, it becomes 1, other one will be 0. That means there is a possibility for having 0, 1 or 1, 0 on XY. Which one is correct? Functionally, we cannot decide. Functionally, we cannot decide either it is 0, 1 or 1, 0. When 0, 0 outputs are there, I am applying 0, 0. When you are applying 0, 0, it is possible to have either 0, 1 or 1, 0 on outputs. Which one is correct if you are asking? I cannot say. I cannot say. I cannot determine. It is not a deterministic output. Then which one is correct? I cannot determine. I cannot say particularly either it is 0, 1 or 1, 0. If you are asking particularly which one is correct, I cannot say. I cannot say, I cannot determine. I cannot determine is called indeterminate. What is it here? XY can be either 0, 1 or 1, 0. Which one is correct? Cannot be determined. Which we name it as a indeterminate. See, point should be understood correctly. When we are getting into SR conditions also, we should know what is indeterminate. Right? Simply we are remembering the table. No. Wherever we are leaving some points or assumptions or remembering, there only they are framing questions. Please understand here. When 1, 1 is applied, output is 0, 0. Immediately in the next sequence, if you are applying 0, 0, output can be either 0, 1 or 1, 0. Which one is correct? I cannot say. But what is going to decide either it is 0, 1 or 1, 0 is here propagation delays of these. When these two gates are considered with propagation delay, if less propagation delay is there, can change early, then other one will be 0. So if this is having less delay, then it becomes 1, other one will be 0. Or one more parameter also is important. What is it here? A is changing from 1 to 0. B is also changing from 1 to 0. This 1 to 0 may not be changing exactly at common point. What is here? So this is changing from 1 to 0. It was 1, now it is becoming 0. It was 1, it's changing from 1 to 0. That means that 1 to 0 changes may not be occurring exactly at common point of time. Then if A is becoming 0 first, it becomes 1. If B is becoming 0 first, it becomes 1. So finally, propagation delays and relative changes of A and B can decide will it be 0, 1 or 1, 0. But what about functionally? Functionally, we cannot decide will it be 0, 1 or 1, 0, which we say that it cannot be determined either 0, 1 or 1, 0. Right? So what is the reason for seeing this indeterminate? 1 1 followed by 0 0. Reason for indeterminate is the 1 1 followed by 0 0. If 1 1 followed by 0 1, there won't be any problem. 1 1 followed by 1 0, there won't be any problem. 1 1 followed by 0 0 is causing indeterminate. What do you mean by indeterminate? Maybe 0 1, maybe 1 0. Which one is correct? We cannot say functionally. Functionally, we cannot determine is named as a indeterminate. Functionally, we cannot determine is named as a indeterminate. So, reason for indeterminate is in this NOR gate, 1 1 conditions followed by 0 0 in a sequence. Then what will be on XY cannot be determined. So, here itself I mentioned when you are applying 0 0, it remains in the previous when XY are 0 1 or 1 0. When you are applying 0 0, it remains in the previous conditions apply XY are 0 1 or 1 0. When you are applying 0 0, outputs were 0 0. When you are applying 0 0, outputs were uncomplementary. In such conditions, what will be remembered cannot be determined. In the memory element, will it be 0 or 1? We cannot say. That's what we are saying indeterminate. When you are trying to remember by applying 0 0, what will be remembered at X and Y? If you are considering X is the data, is X is 0 or 1? Which one is correct? We cannot say. The contents of memory element, is it 0 or 1? Cannot be determined. That is called indeterminate. That is called indeterminate. I hope you are following. When you are applying 1 1, it is seen uncomplementary outputs. Immediately, if you are applying 0 0, will it be 0 1 or 1 0 on XY? Cannot be determined. That is named as a indeterminate. Important thing, reason for indeterminate is 1 1 followed by 0 0. It is not 1 1 alone, it is not 0 0 alone. 1 1 followed by 0 0 in NOR based memory element. If you are understanding this, yes. Yes. Joseph, that's what I have done. Why should I analyze the upper gate first? Again, if you start analyzing with the bottom gate first, we are getting other output. Joseph, have you understood? Because it's memory element Bhaskar, what is going to be there, we don't know. Yeah, Nagalingeshwar Rao, I'm going to address that question. Please wait. Please wait. So, what do you mean by indeterminate here? What is it? 0 1 or 1 0? Which one is correct? We cannot determine. Be clear. No other things. Only either 0 1 or 1 0. Which one is correct? We cannot determine. That is called indeterminate. 0 1 or 1 0. We cannot determine. So it can be 0 1 or 1 0. These two only. But which one is that? We cannot see. That is called indeterminate. It is called indeterminate. Yes. I hope. Yes, Pawan Kumar. So if you are applying 1 1, right? If you are applying 1 1, right, you are getting 0 0 output. That is not indeterminate because we are saying that it will be 0 0 deterministic output. For 1 1, we are getting 0 0 output. It is deterministic output. But 1 1 followed by again 0 1 or 1 0, there won't be such problem. 1 1 followed by 0 0 input conditions. 1 1 input conditions applied. In the next immediate sequence, we are applying 0 0 input conditions. There, we are in confusion whether data in the memory element is 0 or 1. That is called confusion, cannot be determined, which we name it as a indeterminate. Indeterminate. Very good. Good question, sir. Because most of you may be new to this type of analysis, sir. You might have escaped, right, with 1 1 invalid. Because there is no valid function. Yes, expected functions are completed. There is no valid function with 1 1. But what happens if I apply? Logically, we can analyze. That's what we are doing. That's what we are doing, right? Yes, you can apply, but what will be there, we cannot say. Pawan, what is your doubt? If I'm not clear with your doubt, answer is not clear. Tell me what is your question, because I may not be clear with your question. Please elaborate your question. I'm there to help you. For 1, 1, it can't be 0, 0 now. Still, I'm not understanding, Pawan. Can you please wait? We'll discuss, sir. I will discuss, sir. If you are having doubt, let us have a discussion. So for AND OR gate, is it possible to? Yes, invalid only. But why it is becoming invalid? We need to understand Triveni. It must be complementary, Pawan Kumar. It must be always complementary. It must be always complementary. Otherwise, this problem is happening. So when you are applying 0, 0, when you are applying 0, 0, if X, Y are complementary, then we can guarantee it remains in the same. Otherwise, we cannot guarantee. When you are applying 0, 0, X, Y is remaining in the same. That is guaranteed if X, Y are complementary, either 0, 1 or 1, 0. I hope I have answered your question. Yeah. Pooja, there is no delay means ideal, right? Is it possible to exist? Is it possible to exist? Yes. Yes, Pratyush. Yes. Yes. Now, after understanding this, now let me analyze. I'm going to use one more. What is it here? NAND based memory element. Now let us analyze a NAND based memory element. Similar analysis, very simple now. Once we are understanding this NOR based, NAND based is very easy. Similar analysis we are going to do. Similar analysis we are going to do. Please spend effective time on these analysis. Instead of trying to understand everything at a time. So focus on this discussion again and again. Spend time. Sure, you'll be getting more clarity. Right now, if I use a NAND based memory element, instead of using NOR gates, I'm using NAND gates. Let me say here it is a B, M, and N. I'm using that A, B, and M and N are outputs. NAND based. Instead of NOR gates, now I'm using NAND gates. A, B, M, and N. Let us see one by one. So let me analyze for one valid input combination first, which is 1, 1. 1, 1. What is the NAND gate functionality, which we know? NAND gate, if one input is 0, irrespective of X, output is 1. For NAND gate, if one input is 1, enabled, output is what? X bar. So logic 1 is enabling, logic 0 is disabling. For this NAND gate, one input is 1 means output is complement of other input. What is M now? N bar. Any doubt in that? For NAND gate, one input is 1, output is complement of other input. What is other input here? N, it is N bar. For this NAND gate, what we have here? One input is 1, output is complement of other input. Then what we get here, it is M bar. It is M bar. For this NAND gate, one input is 1, output is complement of other input. Yes, it is M bar. When I substitute N equals to M bar, then what we can see here? M bar whole bar is a M. And similarly, M equals to N bar whole bar, it is equals to N. It is equals to N. Any doubt in that? Yes, again it remains in the same. For AB, 1 condition, M and N are previous. Once again, same condition. What is it here? M and N must be complementary. Once again, same condition. M and N must be complementary. Once again, when AB are 1, when AB are 1, outputs are complementary. Then it remains in the same. When AB are 1, the circuit is in remembering. It is in stable condition. It is not changing. So it remains in the same. Again, conditions apply. M and N are complementary. M and N are complementary. When AB 1 applied, M and N are remains in the same if M and N are complementary. What happens if it is a uncomplementary? I'm going to talk once again. So for 1, remember it. Completing one important one. What is it here now? If AB are 0, 1. What is it here? A is 0, B is 1. If A is 0, B is 1, what happens? Which one should be analyzed first? The gate which is connected to A or B? Which one should be analyzed first? The gate which is connected to disable input, because when we know disable input is there, I can say particularly what will be the output. No doubt in that. Correct? When it is connected to disable input, I don't need to know what is the other input to say output. Yes, pakka M equals to 1. Until you keep this as 0, it will be 1. No doubt in that. What about N? Doesn't matter what happens for N. Once M is becoming 1, for this NAND gate we are having 1, 1. Output is what? 0. Output is what? 0. Anyone has any questions? As it is 0, it becomes 1. Once it is becoming 1 for this NAND gate, 1, 1, it is a 0. Irrespective of existing, it becomes a Mn 1, 0. Mn 1, 0. I hope everyone is understanding that as it is disable input, analyzing first. Once we are getting this, I can say what is the output of this gate. Why? I should know what is the other input also to say output, because this logic 1 is enable input. As this logic 1 is enable input, this gate is expecting what is the other input also. For that, I should know what is the M value. Then I can say what is the N value. Why? It is connected to disable input. Without knowing N also, we can say M. Once we are knowing M and N can decide here output is 0. See here, when you are getting that 1 here it is 1, 1, 1, it is 0. But here, I don't need to know what is N value. Once it is 0, confirming output is 1, because 0 is disable input. I don't need to know what is the N value. Without knowing N value also, I can say M value is 1. Once we are getting 1 here, I can say this gate output, because it is connected to 1 which is enable input. It is expecting what is the other input also to say output. Yes. When you are connecting 0, 1 or 1, 0 inputs, always start analyzing with the gate which is connected to disable input. Here we started with 1 first, because 1, 0. Then once you are getting 0, for 0, 0 it is 1. If it is connected 1 here, we are confirming here 0. For 0, 0 it is 1. That's what we started. What is it here? Whenever it is applied complementary inputs 0, 1 or 1, 0, we need to start analyzing the gate which is connected to disable. Yes, when you are applying 1, 0, when you are applying 1, 0, once again let us analyze here. What we are applying? 1, 0. Here it is 1, 0. When it is 1, confirming here it must be 0. Why? Disable gate. Disable. Once it is becoming 0 for this NOR gate, 0, 0, it becomes a. Sorry, I'm doing wrong. I'm doing wrong. See, what is it here? As it is 0, it becomes 1. Once it is becoming 1 for this NAND gate 1, 1, it is 0. So 0 should be analyzed first, because NAND gate disable input is logic 0. As it is 0, it becomes 1. Once it is becoming 1 for this NAND gate 1, 1, it is 0. It is 0. I hope you are understanding. For this NAND gate, as one input is 0, it becomes 1. Once it is becoming 1 for 1, 1, NAND gate output is 0. Yes, Mn are becoming 0, 1. Valid inputs are completed, expected functions are completed. Valid inputs are completed, expected functions are completed. What is that? Remembering, modifying to 1, modifying to 0. Yes. When you are applying 0, 0. When you are applying 0, 0. What happens, sir? When you are applying 0, 0, what is it here? Both the gates are disabled. Both the gates are disabled. Then what is the output? What is the output? 1, 1. Again we are getting uncomplementary outputs. Check it correctly. When we are applying 0, 0, 0 is invalid. But what happens if I apply 0, 0? Yes, 0, 0 is applied. We are getting 1, 1 uncomplementary outputs. In the next sequence inputs, if I am applying 0, 1, 1, 0 will be the output. If I am applying 1, 0, it becomes 0, 1. But if I am applying 1, 1, what happens? Let us see. After applying 0, 0, immediately if you are applying 1, 1. So for 0, 0, already outputs are 1, 1. Now I am applying 1, 1. Then if you are analyzing this NAND gate, one input is 1, one input. For 1, 1, NAND gate output is 0. Correct. Once it is becoming 0 for this NAND gate 0, 1, NAND gate output is 1. NAND gate output is 1. Why you are analyzing this gate first? No, I can analyze this gate also. With 1 and 1, for 1, 1, NAND gate output is 0. If you are getting 0 here, 0, 1, here it will be 1. Earlier analysis it is giving 0, 1. Now we are getting 1, 0. Which one is correct? Again, same problem. What is it? Cannot be determined, which we name it as a indeterminate. Again, same results. What is that here? Propagation delays are not same and relative changing, because A is changing from 0 to 1, B is also changing from 0 to 1. These changes may not be exactly at common point of time. Whichever is changing early can change the gate output first, then other one will be opposite. So finally, what is it here? When 0, 0 is applied, uncomplementary output. Immediately, if you are applying 1, 1, either outputs can be 0, 1 or 1, 0, cannot be determined. Again, we say it is a reason. What is the reason? 0, 0 followed by 1, 1 is reason for indeterminate. What is indeterminate? Either 0, 1 or 1, 0. Which one is correct? Cannot be determined. Cannot be determined. What is here? 0, 0 followed by 1, 1. Output can be 0, 1 or 1, 0. Which one is correct? Functionally, we cannot determine, that we name it as a indeterminate. Same thing, simple thing, right? After understanding these two memory elements, let me ask you a question. Let me ask you a question. Right. In the following circuit, it is applied A equal to 0, B equals to 1, A equals to 1, B equals to 1, A equal to 0, B equal to 0, and A equals to 1, B equals to 1. Applied in sequence. What is here? First 0, 1, next 1, 1. First 0, 0, next 1, 1. This is sequence. What do you mean by this, sir? AB in sequence like this: 0, 1, 1, 1, 0, 0, 1, 1 applied in the sequence. What is the outputs P and Q in sequence? Once again, question is in this circuit, AB applied 0, 1 followed by 1, 1 followed by 0, 0 followed by 1, 1. What is that outputs P and Q in sequence? What is the outputs P and Q in sequence? If AB 0, 1 followed by 1, 1 followed by 0, 0 followed by 1, 1, then what is the outputs P and Q in sequence? What is the outputs P and Q in sequence? Now very simple. We can say output. What is it here? PQ for 0, 1. What will be that? 1, 0. For 1, 1 immediately 1, 0. Because remembering. And for 0, 0 now 1, 1. Then what about the next 1, 1? Maybe saying indeterminate. We can say that either 0, 1 or 1, 0. 0, 1 or 1, 0. Yes. Indeterminate. Correct? That is nothing but 0, 1 or 1, 0. So finally, what is it here? This was the question given in GATE 2017 EC. In the following circuit, it is applied 0, 0. Simultaneously, inputs are changed to 1, 1. Inputs are changed to 1, 1. What is the output PQ? Options are given 0, 0, 1, 1, right? 0, 1, either 0, 1 or 1, 0. This is the options. Option A, option B, option C, option B. Which one should I choose now? Option B, either 0, 1 or 1. What is the question? In the following circuit, inputs are at 0, 0. Simultaneously, both the inputs are becoming 1, 1. Then what is P and Q? What is P and Q? This was the question. Right? Satvik, understand question. In the following circuit, inputs are 0, 0. Simultaneously, both the inputs are becoming 1, 1. What will be the outputs P and Q? Right? What will be the outputs P and Q? Inputs are at 0, 0. Then these are changing to 1, 1. These are changing to 1, 1. Let me say that. Stable inputs are there 0, 0. Then 0, 0. Now it is changing to 1. It is changing to 1. Then what will be the output? For 0, 0, what was the output? 1, 1. When you are applying 1, 1, maybe 0, 1 or 1, 0. That's what we have been saying. When 1, 1 uncomplementary outputs are there, if you are applying 1, 1, outputs may be 0, 1 or 1, 0. Which one is correct? Cannot be determined. Thus, the options are given either 0, 1 or 1, 0. This I have been teaching. From the day one, I started teaching for GATE and ESC. 2017, this was the question. Yes, even I can escape that by saying, simple thing. What is it here? By saying this 1, 1 is invalid, 0, 0 is invalid. What happens if I apply 1, 1 and 0, 0? If you're understanding only, you can answer this question, or you can understand what is exactly indeterminate in SR flip-flop. SR flip-flop. So to understand that, instead of remembering, to understand that, I should know what is this, right? Any questions? Yes, yes, Ashutosh. That's what I've been saying. Every concept we have been discussing is important. How they are going to frame questions, we don't know. Don't expect that questions will be repeated which are given previously. No, they are searching for the areas where it is not covered till now. Untapped areas. If you are conceptually clear, you can answer all those questions. So from now, let me take a small break for 5 to 10 minutes. 5 to 10 minutes. I'll be back in 5 to 10 minutes. Then we continue. So break for 5 to 10 minutes. Yes, Bhavani. Here, when you are applying 1, 1, we are getting 0, 0. Understand correctly? Once again, I'm explaining what is exactly indeterminate. When you are applying 1, 1, we are getting 0, 0. In the next immediate sequence, you are applying 0, 0. What will be the output? 0, 1 or 1, 0 cannot be determined. That is called indeterminate. When you are applying 0, 0 in the next immediate sequence, output can be 0, 1 or 1, 0. Which one is correct cannot be determined. That is called indeterminate for NOR gate memory element. Coming to NAND gate, we are getting 0, 0. Output is what? Uncomplementary output 1, 1. In the next immediate sequence, if you are applying 1, 1, what will be the output? 0, 1 or 1, 0 cannot be determined, which we name it as a indeterminate. What happened, Bhavani? I shouted almost 5, 6 times how it is indeterminate and what is happening, right? Okay, for you, let me explain once again. For the NAND gate, if you are applying 0, 0, if you are applying 0, 0, both are disabled inputs, then outputs will be 1, 1, 1, 1. In the next immediate sequence, if I'm applying 1, 1 input, then what should I analyze here? There is no priority which gate should be analyzed first. For this NAND gate, if I analyze 1 and 1, see existing and this one. For 1, 1, NAND gate output is 0. Once this is becoming 0 for this NAND gate, what is input, sir? Here we have a 0 and here it is 1. 0, 1, it will be 1. Why you are analyzing this gate first? No, let me analyze this gate first with existing. So what was there? For that earlier condition, what we are getting? 0, 1. Now, let me erase this. If you are getting confusion, let me erase this now. Earlier analysis was giving 0, 1. Now, why should I analyze this gate first? If I analyze this gate first, what we have here for this NAND gate? 1 and 1. For 1, 1, NAND gate output is 0. NAND gate output is 0. So once you are getting 0 here, now 0 and 1. 0, 1, NAND gate output is 1. So it is now, Mn is what now? 1, 0. Is it 0, 1 or 1, 0? Which one is correct? Cannot be determined. Functionally, we cannot decide will it be 0, 1 or 1, 0. Which one is correct? We cannot determine, which we name it as a indeterminate. Bhavani, right? That's what I said. Analyze the circuits again and again, multiple times. Don't try to understand everything in one analysis. Please spend effective time on these. Very important. You have to understand. So even though after completion of this class, please at least spend 1 hour in understanding these two circuits only. Right? Is it fine, Bhavani, now? Yes, thank you. Thank you for understanding. Yes. Right. In these memory elements, what is it here? It is satisfying expected conditions. Again, there may be a problem in this memory elements also. What can be the problem? Try to focus on my words correctly. One more important thing. So why we are getting that directly? Instead of giving that directly, I'm giving that reason for each and every concept. So understand correctly. So in the NAND based memory element, listen, if you are applying 0, 1, what will be the output? 1 0. Anyone has any doubt? And after that, if you are applying 1 1, what you are expecting? 1 0. Because 0 1 is applied, we are getting 1 0. Immediately, if you are applying 1 1, what happens here? It is remembering. It is remembering. Yes, it continues in 1 0. Is it satisfying condition? Yes, outputs are complementary and I'm applying 1 1 inputs. When I'm applying 1 1 inputs, if outputs are complementary, it continues in the same. That's what we discussed earlier itself. NAND based memory elements, if outputs are complementary and you are applying 1 1, it continues in the same. Before applying 1 1, what was the input? So 0 1. What is the output we are getting? 1 0. Now immediately if you are applying 1 1, yes, it continues in 1 0. It continues in 1 0. That's what we are expecting. That's what we are expecting. So if I say inputs are at 1 1, inputs are at logic 1, then it continues in 1 0. But there is a problem in this. This input may be affected by noise. These inputs may be affected by noise. For example, it is logic 1. But due to noise, this logic 1 is becoming logic 0 for small duration. And again, back to 1. Example I'm considering. Just a minute. Instead of that, let me take for example, A is at 1, but B is affected by noise for small duration. Assume that. This is A, this is B if I consider. A is at logic 1 only, but B is at logic 1, but the B is affected by noise for small duration. Affected by noise for small duration. Once again, A is at logic 1, B is at logic 1. Then it continues in 1 0. But these inputs are getting affected by noise. Assume there is a noise which is changing this B to logic 0 for small duration. Once it is becoming 0, if the 0 duration is sufficient to change the gate output to 1, right? See here, this 0 duration is small. That small is small enough to change the gate output. Then it is becoming 1 because logic 0, NAND gate output becomes 1, irrespective of whatever is their other output, other input, right? So when it is becoming 0, no doubt it becomes 1. Once it is becoming 1 for 1 1, NAND gate output is becoming 0. After that, it is continuing in 1 1. When it is continuing in 1 1, it continues in 0 1. Continues in 0. What was existing data? 1 0. But after some time, what happened here? The contents are changed to 0 1. Are we changing intentionally? No. By noise, it is getting changed. It is getting changed. What is expected? As we have applied 1 1, the contents are guaranteed or which are remembered, which are retained. That's what we are expecting. So as 1 1 is applied, it was 1 0. We are expecting that after some time also it must be 1 0 only. After some time also it must be 1 0 only. But due to noise, it is getting changed. After that, it continues in 1 1, for example. Assume that. Then what happens here? The contents will be 0 1. I have stored a logic 1. Now I'm getting a logic 0. Do you accept it as a memory element? Do you accept this as a memory element? No. Because when I'm not confident about my data which is stored, I'm getting then no use of that. See, once again, I have stored a logic 1 or 1 0 there, but after some time, there is a possibility for getting 0 1 because inputs are affected by noise. Reason for this is circuit is enabled for these inputs always. Circuit is enabled for these inputs always. That means continuously the circuit is responding to the inputs. Continuously the circuit is responding to the inputs. Whenever it is required to modify the contents, only we have introduced the AB inputs. Otherwise, an inverter-based memory element is capable of remembering 1-bit data. So for remembering, it is not required to respond to the inputs. Whenever it is required to modify the contents of memory element, then only it has to be responding to the input. Point should be understood correctly. Even though in remembering conditions, the circuit is enabled for input or circuit is responding to the inputs. That is the reason. If inputs are getting affected by noise, contents also getting changed. Then what you are expecting? Then what do you suggest? Whenever it is required to remember, circuit should not respond to the input. Whenever it is required to remember, circuit need not to respond to the input. Whenever it is required to modify the contents of memory element, there only it must be enabled for input. Circuit is enabled for inputs always. Instead of this, what we are saying here, circuit must be remembering when inputs are disabled, or inputs must be disabled whenever it is required to remember. Inputs must be enabled when it is required to modify the contents of memory. Whenever it is required to modify the contents of memory element, there it must be enabled. Whenever it is required to remember, then it need not to be responding to the inputs. Then who is saying that whether circuit is remembering or whether circuit is enabled for input? So who is that? Control signal. Point should be understood correctly once again. So when inputs are enabled continuously, when inputs are affected by noise, contents are getting modified. That is not accepted, because I need to guarantee that the stored data is remained. The stored data is remained. Once again, when you are applying input conditions for remembering, you need to be in a position to say that, yes, it will be remind. But what is happening here, as the circuit is enabled for inputs in that remembering conditions also, circuit is responding to the noise variations or input variations due to noise. Because of that, contents are getting modified. I am not changing the inputs. The inputs are getting affected by noise. Because of that, contents are getting modified. That is the reason I need to have a control on this circuitry to say that circuit is in remembering condition or circuit is enabled for inputs. Who is going to decide that? Control signal. What is that? Control signal is deciding. Control signal is deciding whether it is enabled for input or disabled input, or whether the circuit is in remembering condition or enabled for modifying the contents. Then this memory element is not directly applied with inputs. Then inputs are controlled from another control circuitry. Yes, once again, what is it here? NAND based memory element. NAND based memory element. NAND based memory element. Inputs are not directly applied. Inputs are applied from a control circuitry. From a control circuitry. Let me see, it is control signal. Let me see, it is control signal. If I say A, B are inputs, what I've done here, there is a control signal which is enabling inputs, disabling inputs. Right? Let me say it is X and Y. Now you need to understand correctly. Focus on this. Control signal is there, AB inputs are there, outputs are X and Y. Outputs are X and Y. Let me analyze this circuit for extra input, which is control also. Control also. Now, control AB, then XY. When control is zero, understand correctly. When control is zero, then what happens, sir? Irrespective of AB, outputs are 1, 1. Any doubt in that? When control is zero, now it is disabled for AB. It is not responding to AB because zero, one input is zero, output is NAND gate output is 1, NAND gate output is 1. Then even though you are changing A and B, there won't be variations here. When 1, 1 is applied, already we discussed that NAND based memory element will be in remembering condition. When 1, 1 is applied here, this NAND based cross coupled NAND based memory element remains in X and Y. Remains in X and Y previously existing. Maybe either 0, 1 or 1, 0. Assuming XY are complementary, when you're applying 1, 1, it remains in the same. So when control is 0, it is not responding to AB, XY are previously existing. Previously existing. I hope you are following. When control is 0, AB, it is not responding. Even though variations are there on AB, there won't be variations in NAND gate output first level. Then if you don't have variations here, then there won't be variations in the contents. Control equals to 0 is confirming that circuit is in remembering condition. It won't get modified the contents. You can guarantee? Yes, because even though there are variations on A and B n number of times, there won't be variations here, there won't be variations here. When control is 0, it is disabling inputs. It is disabling inputs. When it is disabled for inputs, even though there are variations on A and B, there won't be variations in outputs X and Y. Am I right? When control is 0, right? AB, you may apply any inputs, then there won't be any variations in the contents of memory elements. That means X, Y are not getting modified. It is previous only. It is previous only. Now, when control is becoming 1, there is a possibility for responding to AB variations. Now, control is 1, enabling AB. Control is 1, enabling AB. So, when control is 1, when control is at logic 1, now you may apply AB 0, 0, 0, 1, 1, 0, 1. Now this circuit is responding to AB according to your inputs. If required, we can modify the contents. Wherever it is required, modify the contents. There we can enable input. There we can apply expected inputs to get modifications here. To get modifications here. Try to understand correctly. When can we modify the contents of memory element? When control is at logic 1 only. When logic 1 applied here, now the circuit is enabled for AB. Now AB can be right, anywhere. Let me say 1 by 1, AB 0, 0. When AB 0, 0 applied, when AB 0, 0 applied, once again we are getting 1, 1 only. Once again there won't be any change in the contents. Again it is a previous only. Even though it is enabled, if you are applying 0, 0, there won't be any change in the contents. There won't be any change in the contents. Once again, whenever it is enabled, you are applying 0, 0. When you're applying 0, 0, once again, here it is 1, 1 only. Once again, XY are previous only. XY are previous only. Hold on. Every question will be cleared. Please wait. Now, when control is at 1, ABR 0, 1. ABR 0, 1. What is it here? A equal to 0, B is equals to 1. Check once again. What is it here? When control is at 1, AB 0, 1 is applied. When AB 0, 1, what does it mean by this 0, 1? It is 1, 1, 1, it is 0. Then what should it? Forget about this circuit now. Now we need to analyze this one. As it is 0, it becomes 1. As soon as it becomes 1 for 1, 1, it is a 0. What is it here? X is 0, Y is 1. X is 0, Y is 1. Any questions? When control is 1, AB01 is applied, then XY are becoming 0, 1. XY are becoming 0, 1. Correct? Any doubt in that? When control is at 1, I am applying 0, 1. For 0, 1, it is 1. For 1, 1, it is 0. As it is 0, it becomes 1. As soon as it becomes 1 for 1, 1, and get out with XY is becoming 0, 1. Now, when control is at 1, if I am applying 1, 0, check it correctly. When control is at 1, I am applying 1, 0. I'm applying 1, 0. If I'm applying 1, 0. If I'm applying 1, 0. It is 1, it is 0. Then what happens here? 1, 1, it is 0. 1, 0, it is a 1. It is 1. Once it is becoming 0, no doubt, it becomes a 1. Once it is becoming 1 for 1, 1, and you get out to 0. I'm using same concept so far we have discussed. Simple thing. Once it is becoming 0, no doubt it becomes 1. Once it is becoming 1, 1, 1, it is changing to 0. So after that, it will be continuing in 1, 0. 1, 0. What is it here? 1, 0. Now we are getting into one more important thing, right? Control is 1, ABR 1, 1. Control is 1, ABR 1, 1. Then what happens here? ABR 1, 1. When control is 1, ABR 1, 1. Then what we get here? For 1, 1 it is 0. For 1, 1 also it is 0. As we are getting 0, 0 here, no doubt these two will be 1, 1 again. These two will be 1, 1 again. I hope everyone is following. Control is at 1, ABR 1, 1. For 1, 1, it is 0. For 1, 1, it is 0. For 0, 0, what we get here? Both are 1, 1. Yes, we are getting again uncomplementary outputs 1. Uncomplementary outputs 1, 1. Okay, fine. We have analyzed for each and every combination what will be the output. But what is its functionality? Let us see. Right? What is that functionality? Let us see. Now, what is the circuit? Some of you might have already studied this. What is the circuit? What is the circuit? You might have studied already. Yeah, Toej Akshudu, it is not yes. It is not flip-flop. It is a SR latch. SR latch. Don't say it is flip-flop. So much time is there to see flip-flop. At this moment, what I say, it is a latch. It is a latch. It is SR latch. Now, before that, before deciding which one is S, which one is R, let me decide this is Q, this is Q bar. Once again, these two are X and Y are replaced with the Q and Q bar. If I say this is Q, this will be Q bar. So what is S? What is R? It is set, it is reset. Am I right? What do you mean by setting? Making Q equals to 1. What do you mean by resetting? Making Q equals to 0. When do you expect setting the Q? When S equals to 1. When do you say resetting? When R equals to 1. S equals to 1, R equals to 1. Setting and resetting. Check it correctly. So S and R, its naming is set and reset is nothing but making Q equals to 1, Q equal to 0. So when S equals to 1, setting the Q, making Q equals to 1. When R equals to 1, resetting the Q, making Q equal to 0. Once you are deciding X and Y are Q and Q bar, Q and Q bar, Q and Q bar. If I say these are Q and Q bar, in these two, which one is S, which one is R, we need to decide. So if you are observing, here it is setting. Here it is setting. Am I right? Q is setting. And here it is resetting. So setting when S equals to 1. Resetting when R equals to 1. That means these two, here A equals to 1, it is setting the Q. B equals to 1, resetting the Q. Then A is S, B is R. So these are S and R. These are S and R. So not only this, we need to understand one more thing. Please focus on this. Right, we are going to do a final table of this SR. So until that, please focus on my words correctly. So I hope you might have understood this is SR latch. SR latch. Instead of A and B, now what is that here? S and R. What is it here? S and R. It is Q and Q bar. Now, so what we have understood here, control equals to yes, yes, Anand, yes. Its functionality is that only, enabling and disabling only. Enabling inputs, disabling inputs. Disabling inputs for remembering, enable inputs to modify the contents. To modify the contents, enabling the input. Disabling the inputs, remembering or storing. That's what we are understanding. Now, when do we observe it is remembering the data? Sahil Singh. Yes is set. Setting is nothing but making Q equals to 1. Setting the Q. Set and reset. Reset is nothing but making 0. Set is nothing but making 1. Set, reset. Set is nothing but making Q equals to 1 when S equals to 1. Resetting is nothing but making Q equal to 0 when R equals to 1. See, when Q equal to 0, Q is becoming 0 when R equals to 1. Satisfying, resetting. When Q is 1, if you are observing, S equals to 1. S equals to 1, setting the Q, R equals to 1, resetting the Q. S equals to 1, setting the Q, R equals to 1, resetting the Q. That's it. Now, control equals to 0, control equals to 0, remembering. Control equals to 1, control equals to 1, enabling the input, sensing to the input. Once again, what is it here? Control equals to 0, remembering the contents, remembering the content. When control equals to 1, then it is enabled for inputs. There is a possibility for modifying the contents. So once again, finally, control equals to 0, remembering, control equals to 1, sensing to the inputs. Point should be understood correctly. Control equals to 0. Control equals to 0. Control equals to 0. Disabling inputs, it is remembering. It is remembering. Control equals to 1, enabling the inputs. Enabling the inputs, then it is a sensing the inputs. Control equals to 0, disabled for inputs, disabled for inputs, then it is remembering. Control equals to 1, enabled for inputs, sensing to the inputs. Sensing to the inputs. I hope you are following. I hope you are following. Is there any doubt? Now, we need to understand two more terms. Q of n plus 1, Q of n. What is the naming of this? Already you might be knowing Q of n plus 1 is next, Q of n is present. Next means what? Present means what? What is next? State of Q after responding to the inputs. What is it here? State of Q after responding to the input. What is Q of n? State of the Q before sensing to the inputs. Once again, Q of n plus 1 is a state of Q after sensing to the input. Q of n is a state of Q before sensing to the inputs. Before sensing to the input. Once again, Q of n is a state of Q before sensing to the inputs. Q of n plus 1 is state of Q after sensing to the input. Another way we can say, remember, my wording is important to understand this. Q of n is a stored value at Q before sensing to the inputs. Q of n plus 1 is a stored value at Q after sensing to the inputs. Q of n is a stored value at Q before sensing to the inputs. Q of n plus 1 is a stored value at Q after sensing to the inputs. Once again, naming is important. Q of n is a stored value at Q before sensing to the inputs. What is Q of n plus 1? Stored value at Q after sensing to the inputs. If anyone is having any doubt, just repeating once again, follow my words correctly. Q of n is a stored value at Q before sensing to the input. Q of n plus 1 is a stored value at Q after sensing to the input. What is the conditions for storing the data? Control equals to 0. What is the conditions for enabling or responding or sensing to the input? Control equals to 1. Once again, control equals to 0. It is sensing to the, control equals to 0, disabling inputs, it is remembering, it is storing the data. When control equals to 1, enabled inputs, control equals to 1, enabled inputs, sensing to the inputs. Control equals to 0, storing the data. Control equals to 1, sensing to the input. Once again, control equals to 0, storing the data. Control equals to 1, sensing to the input. Once again, control equals to 0, storing. Control equals to 1, sensing to the input. Q of n is a stored value at Q before sensing to the input. Q of n plus 1 is a stored value at Q after sensing to the inputs. Once again, the table we are going to write is very important, which you may be knowing. How we got, you may not be knowing that. That is the reason I'm explaining clearly. Q of n, I'm repeating once again, Q of n, stored value at Q after, Q of n is stored value at Q before sensing to the input. Q of n plus 1 is a stored value at Q after sensing to the input. Once again, Q of n is a stored value at Q before sensing to the input. Q of n plus 1 is stored value at Q after sensing to the input. What are the conditions for storing the data? Control equals to 0. Is there any doubt in that? No. Control equals to 0, No doubt it is storing the data. Control equals to 1, enabling input, sensing to the inputs. Yes. Once you are understanding this, let us make a table here. Right? Understand correctly. Whether you are writing this table or not doesn't matter. What I am going to explain, that is very important here. Right? Focus on this. Now, S R Q of n plus 1. SR is 0, 0. What we are observing? Prithviraj, Katta Prithviraj. What happened? Please wait. SR is 0, 0. What is that? Previous. Means what? Q of n plus 1 is also Q of n only. Whatever is there before sensing to the inputs will be after sensing to the inputs also. When SR is 0, 0, Q of n plus 1 will be Q of n itself. Because it is previous. When SR is 0, 0, we are saying it is previous. Previous is nothing but Q of n itself. When SR is 0, 1, 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 what we are observing? Q. When SR is 0, what we are observing? Q becoming 0 irrespective of existing. I'm talking about only Q, assuming Q bar is complementary. Right? So Q is becoming 0 when SR is 0, 1. Any doubt in that? Irrespective of Q of n available, Q of n plus 1 will be 0 when SR is 0, 1. When SR is 1, 0, when SR is 1, 0, when SR is 1, 0, what we get here? When SR is 1, 0, what do we get here? Q is 1. Q is 1. Right? I hope no one is having any doubt. You can mention in the chat box, till this, do you have any doubt? SR is 0, 0. Previous is nothing but Q of n. When SR is 0, 1, irrespective of Q of n, it becomes Q 0. When SR is 1, 0, Q becomes 1. Q becomes 1. Right? Correct? Is there any doubt in this? Right? That's it. Now, last one we need to analyze. SR is 1, 1. What is Q of n plus 1? SR is 1, 1. What is Q of n plus 1? When SR is 1, 1, what is Q of n plus 1? Try to understand what I'm going to explain. What is Q of n plus 1? The statement I mentioned, stored value at Q after sensing to the input. What is Q of n plus 1? Stored value at Q after sensing to the inputs. Once again, Ramesh, please wait. When SR is 1, 1, what we need to write? Q of n plus 1. What is Q of n plus 1? Stored value at Q after sensing to the inputs. Right? With respect to control, if you are observing where it is sensing to the inputs, where it is storing, when control equals to 1, when control equals to 1, sensing to the inputs. Right? Now, control equals to 0, storing. Observe correctly. Sensing and storing. So what we need to write? Stored value at Q after sensing to the inputs. When control is equals to 1, S equals to 1, R equals to 1 applied. Observe correctly. I need to write Q of n plus 1. What is Q of n plus 1? Stored value at Q after sensing to the input. When enabled, applying S equals to 1, R equals to 1, sensing to the inputs. What is it here? Sensing to the input. When it is sensing to the inputs, we have analyzed Q and Q bar are becoming 1, 1. Now, I need to observe by making control equals to 0. By making control equals to 0, I need to observe what is the stored value. That's what we are writing as Q of n plus 1. Q of n plus 1 is a stored value at Q after sensing to the input. Yes, control is at 1. Control is at 1. applied S equals to 1, R equals to 1. That's what we have analyzed. When control is at 1, right, we are applying SR11. Yes, it is sensing to 1, 1. It is getting Q and Q bar are 1, 1. What is completed till now? Sensing to the inputs. What should I know? What is stored? When control is becoming 0, there I can observe what it is stored. What it is stored. Once again, I'm writing once again. When control is equals to 1, if I'm applying SR11, no doubt we are getting 0, 0 here. When you're applying 0, 0, here we get both Q and Q bar are 1, 1. When I make control equals to 0, there I'm observing storing the data. So when control is made 0, then what we get here? For 0, 1, it is 1. For 0, 1, it is 1. Am I right? Am I right? Yes, it is becoming 1. It is becoming 1. When these two are 1, 1, what is happening for Q and Q bar? What happened here? Control was at 1, SR11 applied. We are getting 0, 0. Both Q and Q bar are becoming 1, 1. That is nothing but sensing to the inputs is complete. Now I need to observe what is stored. For that, I am making control equals to 0. If you are making control equals to 0, no doubt is irrespective of SR. Now we are getting 1, 1. For 1, 1, what will be there here? Same scenario what we have discussed. See, when output is 1, 1, when we are applying 1, 1 for this NAND based memory element, what will be output? 0, 1 or 1, 0? When 0, 0 is applied for NAND based memory element, we are getting 1, 1 output. Immediately, if you are applying 1, 1, what will be the outputs? 0, 1 or 1, 0. That's what we are observing here also. What is it here? Forget about this circuit now. You don't have this circuit. Now 0, 0 is applied, we are getting 1, 1. Immediately what we are getting 1, 1. Then what will be Q and Q bar? Maybe 0, 1 or 1, 0. Maybe 0, 1 or 1, 0. That means what will be Q? Maybe 0, maybe 1. Maybe 0, maybe 1. Then which one is correct? I cannot say. That is named as a indeterminate. I hope you are following now. That is indeterminate. When 0, 0 is applied, we are getting 1, 1. Immediately, what inputs we are getting for this NAND based memory element? 1, 1. Why we are getting that 1, 1 now? When I am applying control equals to 0 to observe what is stored. When control equals to 1, I have applied S equals to 1, R equals to 1, sensing to the inputs is completed. Now, I want to observe what is stored. For that, I am making control equals to 0. When you are making control equals to 0, irrespective of SR, we are getting 1, 1 here. When you are getting 1, 1, already we have 1, 1, you are applying 1, 1. Now, Q and Q bar may be 0, 1 or 1, 0, which is named as a indeterminate. Maybe 0, 1, maybe 1, 0. Which one is correct? Cannot be determined. That's what we are writing as indeterminate. You don't need to understand all this, but just remember this one. SR table is important. Remember this one. What is here? It is to be remembered. So for SR, even though you are not understanding all these ones and zeros, for understanding next levels, you need to know SR table. Why it is becoming indeterminate is also important. Base for this understanding indeterminate is already we have discussed in NAND based memory element, NOR based memory element. We have discussed where is the possibility of getting indeterminate. The same concept is applicable here also, because Q of n plus 1 is a stored value. For storing, control equals to 0. For remembering or storing, control equals to 0. For sensing to the input, control equals to 1. When control equals to 1, it is sensing to the inputs. Then if you are observing what is stored value by making control equals to 0, there we are observing Q and Q bar may be 0, maybe 1. Which one is going to be there? We cannot say. Then what is the stored value at Q now? Maybe 0, maybe 1. Maybe 0, maybe 1. Which one is correct? I cannot say. That's what we are naming it as a indeterminate. So try to understand correctly. So it is a indeterminate. Yes, yes, Sajjan Singh. After sensing to the input to know what is the just a minute. Any questions? Let me stop here for today. If you have any doubts, let me go with the doubts. Yes, Saidamma. Are you there? Yugasri? Yugasri?
Good morning, sir.
Good morning, Ma. Tell me.
Sir, can you open the 3F page, sir?
Okay.
Sir, here the inverter is forward path, na, sir.
Okay.
It is connect the forward path. It any one is the reverse path, then how it is the answer, sir?
What do you mean by forward path or reverse path? It's a ring. It's a circular. There is no forward path or reverse path. It's not like there is a device. It is a right in the forward path or reverse path. If you connect like this, also same, right? Will there be
Sir,
any?
in a straight line only, one of the three is the reverse path means.
No, I am not understanding what is forward path, what is reverse path in this, right? So let me take.
బబుల్ ఫార్వర్డ్ లో కనెక్ట్ అయ్యింది కదా సార్, అదే బబుల్ ఇట్లా రివర్స్ లో ఇక్కడ లెఫ్ట్ సైడ్ లో కనెక్ట్ అవుతే అప్పుడు
బబుల్ ఏంటా? బబుల్ ఏంటమ్మా? ఇది ఏ విధంగా అనేది ఇట్లా కదా? ఇలా ఉంటుందా? అలా ఉండదు కదా. ఒకసారి యుగశ్రీ ఆలోచించు. ఇన్వర్టర్ అంటే ఇలాగే ఉంటుంది, లేకపోతే ఇలా ఉంటుంది. నువ్వు ఎలా కనెక్ట్ చేస్తే అలా అవుతుంది. ఇంకెలా కనెక్ట్ చేయమంటావు బ్యాక్వర్డ్ పాత్ అంటే? ఇది డయోడ్ కాదమ్మా.
Okay.
డయోడ్ అంటే ఇలా చేయొచ్చు, ఎలా ఉంటుంది, లేదంటే ఇలా ఉంటుంది. ఇది డయోడ్ కాదు. అర్థమవుతుందా?
ఓకే
బస్
సార్.
అర్థమైంది అనుకుంటా.
ఓకే సార్.
డౌట్ ఉంటే చెప్పు.
అంటే ఇప్పుడు క్వశ్చన్
ఫోర్స్ఫుల్ గా యాక్సెప్ట్ చేయకు.
ఓకే
డయోడ్
సార్.
అయితే ఇలా చేయొచ్చు, ఇలా చేయొచ్చు.
క్వశ్చన్ లో రివర్స్ లో ఇస్తే సేమే వస్తుందా సార్?
ఎలా ఇచ్చినా సరే ఈ రింగ్ లో నువ్వు ఎక్కడైనా ఇప్పుడు ఒక బ్యాంగిల్ తీసుకొని ఇలా రౌండ్ చేస్తే ఎక్కడ చేసినా అదే కదా, సేమ్ అలాగే ఉంటుంది.
ఓకే.
ఒక బ్యాంగిల్ తీసుకొని రొటేట్ చేస్తుంటే ఏమవుతుందో అలాగే అవుతుంది.
దిస్ ఈస్ నాట్ ఈక్వల్ టు రింగ్ మెయిన్ మెథడ్.
వాట్ ఇస్ రింగ్ మెయిన్ మెథడ్? ఐ డోంట్ నో.
అంటే రింగ్ లో కనెక్ట్ చేస్తే సేమ్ వస్తుంది సార్, అట్లా అని.
అదే రింగ్ లోనే ఇప్పుడు ఎక్కడైనా ఉండొచ్చు, నువ్వు ఎక్కడైనా తీసుకో, ఇక్కడే తీసుకోవాలని లేదు, ఇక్కడే తీసుకోవచ్చు, ఇక్కడ తీసుకోవచ్చు, ఎక్కడే తీసుకోవచ్చు, ఎక్కడ తీసుకున్నా సేమ్ అవుట్పుట్ వస్తుంది.
ఓకే సార్.
రైట్, అంతేనా? ఇంకేమన్నా?
అంతే సార్. థ్యాంక్ యూ సార్.
థ్యాంక్ యూ. అర్పిత్ ఆనంద్.
Sir, slide number 1.
Okay. Slide number 1. Okay.
Sir, here for NAND gate, the delay of both the NAND gates will be unequal. Then only we will be able to analyze it.
In the world, no two things are identical, right?
Sir, here where we are using NAND gates, for 0 1 we are getting 1 0. In that case, the delay of lower one will be more. And when we are
whatever be the delay, when you are applying 0 1 and 1 0, there won't be any problem. Finally, it is settling to the function expected only. Functionally, we are able to say 1 0 output means it will be 1 0 after some time. That's it. There may be delay, but finally, what is stable? 1 0. Right? Even though these are having different delays, not a problem. Arpit?
Yes, sir. Yes, sir.
Right. Understood?
Yes, sir.
Thank you. Thank you. Pranit.
Good morning, sir.
Very good morning,
Sir,
Pranit.
I had a doubt in yesterday's class, sir. Sir, in yesterday you told about 3 representations, na, sir, for logic 0 enable.
Yes, yes.
Sir, can
Yes.
you just repeat that last one, sir? Third representation.
There may be bubble like this. There can be E bar like this. There can be E bar and bubble.
Yes, sir.
This is also logic 0 enable. Logically, don't go with x bar whole bar is equals to x.
Okay, okay, sir.
Right?
Okay.
Logically, you are correct, but with respect to enable, it is not correct.
Okay, sir.
Right? In enable, blindly follow, it is also logic 0 enable. That's what I said.
Okay, sir.
Completed. Bhavan.
Good morning, sir.
Very good morning, ma'am.
Sir, my doubt is from today's class, sir. It is 4F slide. Just once open 4F slide.
Okay. Yes.
Sir, it's not 4F, sorry. It's SR truth table, sir. SRQ bar. No, sir.
No, it is not there. Not required to remember. That is the reason I erased. What is your doubt? Let me know.
For control 0, sir, for control 0.
Control 0.
The yes, for control 0, the
Yes,
for Q bar, the answers are the previous cases.
Yes, previous.
And for then next C is equals to 1 for SR 0 the answer is the Q bar answer is previous.
Previous.
For second case, you are saying that this is modifying. This case is for modifying.
No. Actually, with control equals to 1, by applying the expected inputs, we can modify. What we are doing here, when control equals to 1, it is possible to modify. Every time it is not getting modified, right?
Yes. For second
Control
case, it
equals,
is just
when control
remembering.
equals to 1, whenever it is required to modify, I can apply expected inputs, right? There is a possibility for modifying the contents of memory element when we are making control equals to 1.
Then for second case, it is remembering, right, sir? We
Okay,
can remember by this.
It is remaining in the C. Yes.
Okay. Okay,
Yes.
sir.
Right.
Then the next doubt is
But there will be a problem. For remembering, I should not do this. For a longer time, I want to remember. Then what should I do? Control equals to 1.
first case.
Yes.
Okay, sir. Sir, another doubt is like last slide, last concept. You have told like sensing, storing.
Yes.
So for last
Control equals to 1, S equals to 1, R equals to 1 applied. For these inputs, the circuit is sensing. Am I right?
why not this concept is applicable for third case, sir? Like S is equals to 1, R is equals to 0.
For those also. See, S equals to 1, R equals to 0 is applied, for example.
Okay.
Then what happens here? Control equals to 1, S equals to 1, R equals to 0. Here it is 1, here it is 0. Here what we are getting? 1, 0, right?
Sir, for last case, you
Listen,
have
listen.
done control 0, sir. Control to 0.
Listen, Bhavani, listen. So what I'm saying that I'm observing that 1, 0 is sensed.
Okay.
After sensing, what will be stored value? Now control equals to 0. We are getting 1, 1. For 1, 1, what will be here? 1, 0 only.
Yes.
After sensing 1, 0, what it is storing? 1, 0 only.
1, 0.
Right.
Okay, sir. Thank you,
It is for
sir.
all. It is for all. But as it is required the last stage, I am explaining. Because how we are getting indeterminate, you may not be knowing. Simply remembering that, right?
Okay, sir.
No. Now,
Thank you, sir.
not remember what is
Understood.
happening. We are understanding. Thank you, Bhavani.
Okay.
Ujjwal.
Good morning, sir.
Very good morning, Ujjwal.
Sir, my question is, have been there questions with delay in circuit gates? If so, can I determine the output?
No. Don't expect that.
So gate delays will be always same.
Assuming that, we are proceeding.
Okay, that is also.
Triveni.
Yes, sir.
Yes.
సార్ నాది డిమక్స్ డీకోడర్ గురించి సార్ డౌట్.
Okay.
డిమక్స్ డీకోడర్ రెండు ఒకే ఫంక్షనాలిటీ అన్నారు కదా,
అవును.
అప్పుడు ఎందుకని రెండు స్పెషల్ గా యూజ్ చేశాను సార్? అంటే డిమక్స్ అని
డిమక్స్ లో ఒకటి అర్థం చేసుకోవాలి. డిమక్స్ లో ఇన్పుట్ డేటా విల్ బి ట్రాన్స్ఫర్ టు రెస్పెక్ట్ అవుట్పుట్ కదా. ఇన్పుట్ డేటా 0 ఉన్నా 1 ఉన్నా ఆ డేటాని రెస్పెక్ట్ టు రిసీవర్ కి వెళ్తుందా లేదా కదా. ఇన్పుట్ డేటా 0 కావచ్చు 1 కావచ్చు, రెస్పెక్ట్ టు రిసీవర్ ఆ డేటాని రిసీవ్ చేసుకుంటుంది. కానీ డీకోడర్కి వచ్చేసరికి ఆ రిసీవర్ ని ఎనేబుల్ చేయాలా డిజేబుల్ చేయాలా అనేది అవుట్పుట్ లైన్స్ చూస్తున్నాం. ఇక్కడ రెస్పెక్ట్ టు డేటా ట్రాన్స్ఫరింగ్ యూజ్ చేయట్లేదు. డీకోడర్ దేనికి యూజ్ చేస్తున్నాము? జస్ట్ ఎనేబులింగ్ రెస్పెక్ట్ టు బ్లాక్స్. అర్థమవుతుందా? అదే డిమక్స్ లో కనుక అయితే ఏదైతే ఇన్పుట్ డేటా ఉందో దాన్ని అవుట్పుట్ రిసీవర్ కి పంపించగలుగుతుంది.
10:1 మక్స్ చెప్పారు కదా మీరు. 10:1 మక్స్ సార్. Using
10:1 మక్స్.
Using 2/1 మక్స్. అందులో I8 I9 S0 తీసుకున్నాం కదా సార్.
I8 I0 or
రిప్రజెంట్ చేయడానికి
yes,
S3
differentiate చేయడానికి S0
తీసుకుని
తీసుకున్నాం.
S0 తీసుకున్నాం, కానీ మనం అక్కడ S2 తీసుకోలేదు, S1 తీసుకోలేదు. అవి 0 ఉన్నాయని కదా సార్ తీసుకుంది.
యాక్చువల్ గా ఏంటంటే ఇక్కడ మనకు పాసిబిలిటీస్ అబ్జర్వ్ చేసుకోవాల్సింది ఏంటంటే సెలెక్ట్ లైన్స్ ఏవై జనరేట్ చేస్తున్నాము 000 నుంచి 1001 వరకు మాత్రమే జనరేట్ చేస్తాం. సెలెక్ట్ లైన్స్ లోనే కండిషన్ పెట్టుకున్నాను నేను ఆప్టిమల్ గా ఇలా డిజైన్ చేయాలనుకున్నా. అంటే పాసిబిలిటీస్ ఏంటి సెలెక్ట్ లైన్స్ మీద 0000 నుంచి 1001 వస్తుంది. అలా వచ్చినప్పుడు మనకు ఫంక్షనాలిటీ ఎక్కడ ప్రాబ్లం రావట్లేదు. అది ఆప్టిమల్ పాసిబిలిటీ.
అప్పుడు I8 I9 ఇప్పుడు మీరు 10:1 కావాలన్నారు. అప్పుడు మనం ఇంకొక మార్క్స్ యాడ్ చేసుకుంటాం S0 దగ్గర.
అవును.
అప్పుడు మనం S1 S2 రెండు S1 S2 రెండు తీసుకోకుండా ఓన్లీ S0 ఒక్కటే తీసుకున్నాం కదా.
తీసుకున్నాం.
అప్పుడు అలా తీసుకోకపోయినా మనకి ఏం ఎఫెక్ట్ కాదా? అంటే కౌంట్ చేసేటప్పుడు ఇన్ని మార్క్స్ మనల్ని ఆప్షన్స్
ప్రాబ్లం రావట్లేదు. ఫంక్షనాలిటీలో ప్రాబ్లం రావట్లేదు.
ఫంక్షనాలిటీలో ప్రాబ్లం రావట్లేదు సార్. ఇప్పుడు సపోజ్ మమ్మల్ని ఒక క్వశ్చన్ అడిగారు అనుకోండి, ఎన్ని మార్క్సెస్ యూజ్ చేశారు 2/1 మార్క్స్ 10:1 కి అని అడిగారు అనుకోండి.
9.
అప్పుడు S0 S1 తీసుకోలేదు కాబట్టి మనం చెప్పని అవసరం లేదు. ఇప్పుడు అదే 11:1
వచ్చేసరికి 11 వచ్చేసరికి మళ్ళీ 10 వస్తుంది. ఎక్కడ వస్తుంది?
S1 కి వస్తుంది. అప్పుడు
S1 లో ఇంకోటి వస్తుంది. చాలా కరెక్ట్ గా ఆలోచించాము.
S1 కి వస్తుంది సార్.
S1 కి వస్తుంది.
సో ఇంకొక 1 మార్క్స్ ఎక్స్ట్రా యాడ్ అయ్యింది. అంతేగాని ఇప్పుడు S2 తీసుకోలేదు కాబట్టి S2 మనం కౌంట్ చేయాల్సిన అవసరం
లేదు.
ఓకే సార్, అదే సార్ డౌట్.
ఓకే అమ్మా, వెరీ గుడ్. ప్రత్యూష్.
Hello.
Yes, Pratyush.
Yes, sir. The last explanation that you gave today, how it is indeterminate for S equals to R equals to 1.
What is it?
I just didn't get that.
This one, right?
For S equals to R.
For understanding
yes.
this, listen, Pratyush. For understanding this, you need to understand this one. In every condition, what is happening?
Yeah, I understood that one.
If you are understanding, nothing is there, right? When control equals to 1, I am applying. When control equals to 1, I am applying
sensing
SR
inputs.
11. Correct?
Yes.
Then it is
Yes, sir.
sensing to the inputs. So then we are getting, what is our first level of outputs? 0, 0. For 0, 0, what we are getting? 1, 1.
Yes.
What is completed till now?
1, 1.
This one
Yes.
only completed, sensing. Then I
Yes,
want
sir.
to
Okay.
observe what will be stored after this. Then you are making control
Okay.
equals to 0 to observe what is stored.
Yes, sir.
When you are making
Yes,
control
sir.
equals to 0, here we are getting 1, 1.
Yes, sir.
Already
1,
output is 1, 1. Now you are getting 1, 1 here. What will be Q and Q bar? 0, 1 or 1, 0.
1, 0.
Yes. What will be at Q? Is it 0 or 1?
Yes,
I
sir.
cannot say,
Indeterminate, sir. Yes, sir. Got that. Thank you.
Right. Thank you.
Thank you, sir.
Thank you. Shivalila.
Good morning, sir.
Very good morning, ma'am.
Sir, I have doubt in 4F frame.
Okay, 4F. Yes.
Sir, if the sequence is like 1 0 0 0 1 1 0 1
1 0.
0 0
Okay.
1 1
Okay.
0 1.
0 1.
Then what will be the output sequence, sir?
Okay, for 1 0, here it is 1 0 means it is 0 1. Then it is 1 1.
Yes, sir.
Then 0 1 or 1 0. Then 0 1, what we get? 1 0.
1 0. Then in between indeterminate form will come, no, sir?
Yes, it is coming.
Okay.
That is the reason we are putting a condition. Don't apply 0 0 input conditions itself. Because if 0 0, we don't have any valid function here. Valid functions are completed already. Apply 0 0.
Okay.
There you are saying that 0, 0 is invalid input combination because there is no valid function for that.
Yes, sir.
That's what we are doing. Don't apply that input conditions at all. That may
Okay.
be causing this problem.
Huh.
Right?
Like in problems, they will ask now, sir. If they ask means final answer, what we have to.
That is correct. Whatever I have written is correct.
Huh. Okay, sir.
Whatever I have written here is correct.
Okay. Like in options, 0, 0, 1, 1, like that they will give no, sir. Which option we have to select? Final answer is 1, 0.
Yes.
That only we have to select.
They won't give only one.
Okay.
They have to specify both. Like this, either 0, 1 or 1, 0. This was a question 2017 KTC.
Okay, sir.
Oh.
Okay, sir. Sir,
Particularly
I
we cannot say. Yeah.
One more doubt, sir. In workbook, they have given and for implementing decoders, can we use AND gate or what like that?
AND gate, right? What is the final outputs? AND gate outputs only, right?
Correct, sir. Correct, sir.
Right.
Okay, sir. Thank you, sir. That's
Thank you. Thank you. Just a minute. Okay. Srimadela completed. Bharat.
Sir, 3F, 3F.
3F.
సార్ అక్కడ ఇన్వర్టర్స్ సిరీస్ అండ్ ప్యారలల్ కనెక్షన్ ఉంటే అప్పుడు ఫ్రీక్వెన్సీ
ప్యారలల్ కాదు నాన్న, రింగ్ అని చెప్తున్నా కదా. రింగులు ఎక్కడ పెడతావని చెప్పు. సర్క్యులర్ గా నువ్వు కూర్చున్నావు 10 మంది, ఎక్కడ కూర్చుంటేంటి? సిరీస్ ప్యారలల్ ఉంది అక్కడ. నువ్వు ఇలా చూస్తున్నావు కదా, యాక్చువల్లీ ఇది రింగ్.
ఓకే ఓకే.
నువ్వు ఎక్కడ పెట్టినా ఒకటే. ఇలా ఉంది రింగ్. సిరీస్ ఏంటి, ప్యారలల్ ఏంటి దీనికి? ఇంకా ఇలా ఉంది.
ఓకే
కదా ఇదంతా రింగ్ సర్క్యూట్ అంటున్నా కదా.
ఓకే ఓకే.
సర్క్యులర్ గా ఉన్నాయి. ఏమైంది ప్రాబ్లం? ఎక్కడ ఉంటే అంతా ఒకటే కదా.
ఓకే సార్.
అంతేనా?
రైట్. థ్యాంక్ యూ.
అంతేనా? ఏమన్నా డౌటా?
ఏం లేదు సార్.
ఓకే, థ్యాంక్ యూ. వంశీ కృష్ణ.
హలో సార్.
హలో
సార్, నా డౌట్ వచ్చి 1F స్లైడ్ లో సార్ ఒకసారి.
ఓకే, ఏ డౌట్ ఏంటి
సార్? ఇక్కడ నార్ గేట్స్ ఉన్నాయి కదా సార్, నార్ గేట్స్ అవుట్పుట్స్ రాశారు కదా సార్.
అవును.
ఇప్పుడు 1 1 ఫాలోడ్ బై 0 0 ఉంది కదా సార్.
అవును.
దాని కింద మళ్ళీ 1 1 ఫాలో అవుతుంది అనుకో, అప్పుడు అవుట్పుట్స్ ఏమొస్తాయి సార్? సేమ్ 0 0 వస్తుంది,
మళ్ళీ 0 0 వస్తుంది అంతే.
డిపెండ్ ఏం అవ్వదా పైన అవుట్పుట్ 0 0?
నువ్వు 1 1 ఇందులో ఏమైనా డౌట్ ఉందా? 1 అంటే డిజేబుల్ 0 అవుట్పుట్, 1 డిజేబుల్ 0 అవుట్పుట్. ఇంతకుముందు ఏముండదు, అవసరం లేదు.
ఓకే సార్, అంతే సార్, నో డౌట్.
ఓకే,
థ్యాంక్ యూ సార్.
శిల్ప.
Hello, sir.
Yes, ma. Tell me.
Sir, my doubt is from indeterminate condition. Last slide.
Of which one? Last one?
SR flip-flop.
Okay. Don't say flip-flop. I did not say it is latch. It is latch. Yes.
Sir, when SR is 1 and control is also 1, our output are Q and Q bar also 1 1.
Yes.
So, sir, it is a invalid condition, means Q and Q bar can't be 1 at the same time.
Yes.
Or when we SR is 1 and we made control 0 now.
To observe what will be stored.
So which is
Then,
invalid, sir?
yeah.
First 1 1 is invalid, or after making control 0 it's 0 1 or 1 0. We can't determine which one we should consider. It's invalid.
1 1 is not having any specific function here. Because to remember we are using this, to reset we are using this, to set we are using. Is there any function here?
No.
then what we say, 1 is not having any valid function in this.
Okay, sir.
1 input condition is not having any valid function in this.
Okay, sir.
Right? If you are applying 1, will there be any expected function here?
No.
No. There is a reason we say 1 is invalid. There is no valid function with SR11. Yes, even though it is sensing to 1, even though it is trying to remember, then what is going to be remembered also we don't know.
Okay,
Will
sir.
there be any use of such memory elements? No. The reason 1 is not having any function, we can say. What do you mean by invalid? There is no valid function.
Yes, sir.
Shilpa,
Yes, sir.
understood?
Yes. Yes, sir. Thank
Thank
you, sir.
Pradeep Kumar.
Good morning, sir.
Very good morning, Pradeep.
Sir, I have doubt, sir, the application of DMOX and decoder.
A decoder is enabling one block.
Yes, sir.
Whenever it is required to enable, whenever it is required to select only one block or one IC, one chip, there we are using decoder. But what is demultiplexer? It is transferring input data to the respective receiver. Understanding?
Functionally, both are same.
It can be used interchangeably, but when we are saying demultiplexer, it is demultiplexing input data. The data will be transferred to one of the receiver, one of the output line. So input data I will be transferred.
Yes, sir.
I may be 0 or 1, both will be transferred. Pradeep Kumar.
Yes, sir.
Serial, it is getting continuously data. The serial data will be transferred to respective receiver, depending on your select line. The serial data is transferred serially to the respective receiver. Are we doing that in decoder? Enabling one, disabling all. That is its functionality. Are we transferring input data to the respective output line in decoder? No. So respective output line can be used to enable the blocks. Interchangeably, they can work. But specifically when we are mentioning demux means, it is transferring the data. Input data will be transferred to respective receiver. So when we are using functionality, or internally it may be same, but where I am using functionality is different, right? When I'm saying demultiplexer, it is used for transfer of the data. When I'm using decoder, I'm using for enabling respective block. That's it. But internally both are same, functionally. But how I'm using this is naming differently. Pradeep.
Yes, sir.
For which purpose I'm using this is naming differently. That's it.
Yes, sir.
Right?
Right. Thank you, sir.
Thank you. Chakravarti.
Hello, sir.
Hello, Chakravarti.
Sir, the first one, the problem that you solved.
Yes.
Sir, in that we could also
Only, right?
short.
Yesterday you have sent that.
Yes. So for that one, if we short the two inputs for the implementing like the 2x4 decoder by 4x16, that is also possible, right?
That is possible. That is possible.
Instead
But
of
which
taking 0, 0.
output lines you are using is important.
Okay, sir.
First two you are shorting to A, second two you are shorting to B.
Yes.
Yes.
Okay, sir.
Right. Venkana. Venkana.
Yes, sir.
Yes, Venkana. Please, it is not audible what you are saying.
Explain again control signal, sir.
Which one control signal you are talking?
In SR slash.
If possible, can you type in the chat box? It is not audible. Sorry, it is not audible. Please type your question. I will check it. Yeah, about tomorrow. Tomorrow you don't have class, digital class. You don't have digital class tomorrow. Yes, Sai Kumar. Yes, there will be difference. You will understand soon, Sai Kumar. That's what I checked your message also on phone. Yes, that you will understand after some more discussions. Please wait, Sai Kumar. Fine. Madhugula Sai Kumar. Right? That difference you will understand soon. Please wait. Okay. Praneeth.
Sir, in the just previous frame, sir, when S is equal to 0 and R is equal to 1, sir.
Okay.
After sensing the output, we make control 0, no, sir, for for observing the stored value at Q.
Yes.
Then for this condition, the output will also become 1, no, sir, here after the first NAND gate.
Hold on. What you are expecting here, when control is at 1, right? SR is
S
applied.
is equal to 0, 1.
S equals to 0, R equals to 1. Let me do that. Okay. One by one, clearly we need to understand. Put on a paper,
Yes.
you will understand more.
Yes, sir,
Control
yes, sir, I
equals
did.
to 1, SR is 0, 1, right?
Yes, sir. Yes,
What
sir.
we get here? 1. What we
1,
get here?
0.
0. Then what we get
Here
here?
0. 0, 1.
Here
Sir.
it is 1. Here it is
0. Sensing
0.
the input is done, sir, now.
Right. What do you do? Control equals to
0.
0. When
Yes,
what
sir.
we are getting here?
1,
1.
1, 1. Yes,
And
sir.
1 is applied. We don't have this right now.
Yes, sir. Yes, sir.
When we are applying 1, it is 0. What will be there?
When we are applying 1, both will be 0, no, sir. Q and Q bar. These are also uncomplementary outputs, no, sir.
NAND gate.
Yes, sir.
1 is applied. Are they disabling?
Yes. Okay, sir.
Right? You are combining one concept from NAND gates, one concept from NOR gates.
Okay.
Right? 1 is applied, remains the same. Because complementary outputs are there. 1 is applied, remains the same.
Okay, previous. Okay, sir.
Right.
Okay, sir.
Okay. Bharat.
Sir, sir, my doubt is in the same slide, if we take control signal as 0, irrespective of SR, so the output will be the previous state, no, sir?
Yes.
So here you wrote the table like for enable 1.
Yes.
So when we are writing the table, that is left side SR Q of n plus 1. So when we take that enable signal, so we will get irrespective of SR,
See,
the output will be
what
Q
I'm
of n.
writing here is excluding this. Remaining I have written.
Yes, sir.
When it is enabled, sensing what will be stored. Enabling, sensing what is stored. Enabling, sensing what is stored. Enabling, sensing what is stored.
That I understand, sir.
Right.
But I am asking about this condition. When it is the control is 0, so it will be Q of n.
Yes,
Irrespective.
Yes.
Okay, sir.
Yes, that's correct.
Yes, sir. That's it, sir.
Okay. Saidamma, did you type a question, please? Param, enjoy. If you want to talk, I will enable once again, Saidamma. You guys say, please wait. Are you there? Okay, Yugashri.
Sir,
Yes.
in this,
Yes. Yugashri, what happened?
sir, I'm audible to you.
Yeah, tell me.
Sir, S equal to 1, R equal to 1, control equal to 1. Then the 0, 0 and the Q is equal to 0 and the Q bar equal to 1 will come, sir.
Check it once again. What you are saying, control equals to, tell me.
1.
Control equals to 1. SR equals to
1.
1.
R equal to 1.
Okay. Then what we get here?
0, 0.
For 0, disabling the gate, right?
Yes.
0, disabling the gate, right?
But
Why are you getting confusion?
the
0,
Q
0
and
is up,
Q
right?
bar is there, na, sir?
So 0, 0 is up. No, no. It is our convention we are using a bar. It is not compulsory to have that Q and Q bar. We are expecting, but in this condition it is not giving. That is the reason we are having a problem with this. You will see.
If the Q is equals to Q bar equal to
Yeah,
same.
it must be Q and Q bar, but we are getting uncomplimentary. There is a problem. Right?
The bar is not compulsory. The
No, that
previous
is just
one you,
naming convention we are using.
okay, this previous one M and N, how you used it, like that you are using Q and Q bar.
Yes.
Okay, thank you, sir.
Thank you. Yes. Anyone else? Okay. See you on Monday.